Hello, 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 and welcome to the wonderful world of matrices. So, let me walk through what I mean. So let's establish our goal. Our goal is to solve a system of linear equations using matrices. So first we've got to define some terms. But remember back in the old days, we could solve a system like this? Well, what are the three methods that you remember? Take a pause for a second and then come back and check your answers here. Now that you've done that, notice that our first method is graphing, and we can graph by hand using our TI or Casio calculators or Desmos, which is by far the fastest. Our second method is solve by substitution, and our third method has two names. We can solve by linear combination, or it's also known as elimination. Why is it called these things? Well, because when you combine the linear equations, they eliminate a variable at first. So we're going to solve using the first one, linear combination. And if you remember how that's done, what we're going to do is our goal is to eliminate variables. So I need to, when I combine, to get 0. So I want opposites. I want opposites, either at the x's or in the y's. Well, it's easiest to look at the very first one, the top one, and make it oppositified to opposite the second by multiplying by a -2 right there. And in doing so, we get this. -2x minus 8y, I'm distributing it all across, equals a +2, because -2 times -1. And now I'm just going to bring down or carry over the exact same bottom equation there. Now, that's step one. I multiplied to get opposite terms. Next, I'm going to combine them by adding them together. Those drop out, which is exactly my goal. And here we get a -3y, and over here we get a 6. So we've combined them. Our next step is just to isolate the variable. In this case, divide both sides by -3, and we get a -2. And now, our last step before we can check is we take this -2 and we're going to place it in any equation we want. We can place it here, or we can place it on the top. It doesn't matter, and neither one of them is better or less better in this case. So I'm going to put it in the bottom one simply because it is already there. So times 5, or excuse me, plus 5 times -2 equals 4. So here I get 2x minus 10 equals 4. Add 10 to both sides to get 14. Divide by 2 to get a 7. So my solution is 7, -2. Of course, you can check that solution by taking the 7 and the -2, placing it here, and when you do your order of operations, you should get a -1, and repeat that process for there as well. If you click here or scan this, you can see solving by substitution and by graphing. And here we can upgrade solving a system with 3 variables, where it gets really, really ugly. But today we're going to also show you how to eventually get to that using your calculator. So, first off, let's introduce what a matrix is. A matrix, and plural is matrices, is a rectangular array of numbers usually displayed in brackets like these here. The dimensions of a matrix are always the number of rows, and rows are the horizontal, by the number of columns, and the columns are the verticals. Okay, so let's look at A, matrix A. And sometimes matrix A is, well, usually we're going to use a capital letter. On the TI calculators, they say stuff like this, A, like so, but we can just call it a capital A. And we do always use capital letters for matrices. So matrix A is a 2 by 3 matrix. A 2 by 3 matrix because it has 2 rows and 3 columns. each of these numbers, the 1, the 4, the -1, each one of them is a matrix element. Matrix element. And it has an address. So in matrix A, up here, the 1, 2 is the first row. So in row 1 and in column 2. So row 1 is this one, and column 2 is this one. So that means the address takes me to 4. Takes me to 4. So let's look at matrix A continuing and find the other ones here. I will do part B here. Then I want you to look at matrix B over here and do those. All right, so let's see. In matrix A, A22. A22. Here's 2, and here's 2. Boop, 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 boop. So that's a 5. There we go. Next up is A13. So here's 1, and here's 3. So it's the -1. And lastly, what is the 3, 3? And let's think about that. 1, 2, oh, there is no 3. So there is no 3. So this doesn't exist. So often you might see this here, which means the null set, there's nothing at all, or does not exist, or not there, something like that. Okay, now please take a gander at B here and do that. Go ahead and pause. Now, 2, 2, 2, 2 is -11. 1, 3 doesn't exist, and 3, 3 doesn't exist either. All right. Now, how does this relate to systems? Let's take a gander here. The nice thing about a matrix is that when you're representing a system, the columns represent an aspect of the original equations. So, for example, the first column is going to be my x's, or a's, or whatever variable we're using. The second column is going to be my y's, and this third column is the equals part, equals something. All right, so that's why there's a little line right here, as if there's a separation. The line represents the equals right there. So for these matrices that we're going to write, we are going to write a little bar, a vertical line there representing the equal. Okay, so what we do is we take the exponents and the constants. This exponent here in front of the first x there is just a 1. So we put a 1 there. The next one is a +4, so I put a 4 there. And lastly, the equals -1, so over on the other side of the bar, I put a -1. And now we repeat ourselves. I put a 2, a 5, and a 4 in for the next one. 2, 5, and a 4 over on the other side. And that's it. That's how we write the system. So how would we write this system with 3 variables? Pay attention to your zeros. Go ahead and try it real quick. Pause, and then come back. So one thing I want to point out to you is that we do have some missing elements here. We have an x, a y, and a z, x, no y, and here I want to put them in lined up form. So I'm going to rewrite things so they are lined up. So x minus 3y plus z is equal to 6. Now x, skip, 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 plus 3z equals 12. And this one here I need to line up. I need to get that x to the other side. So that's a positive 5x because I add it to both sides, plus a y. There's no z, and there is a 1 now. Again, there's no z in this one, so I leave a 0. There's no y in this one, so I leave it blank. Now, the blank is important because the blank is something. Recollect that when there is no y, it's like that, and when there's no z, it's like that. All right, so now how do we write that as matrix? So start with your bracket there, and I'm making mine longer because it's going to be a 3 by 4, it looks like. So I do a 1, a -3, a 1, bring my bar down, and a 6. Now for the second row is a 1, a 0, a 3, and a 12. And lastly a 5, a 1, a 0, and a 1. And then put my bracket, end it like that. And there we go. Now what does this system represent? Pause and go ahead and figure that one out, and then come back here. Well, this is my x's, this is my y's, and that's my equals. So we do 5x plus 2y equals 7, and no x, so I don't even need to write that, just a y, and that equals a 9. And this here is my system, and you do not need that bracket if you don't want, but oftentimes that bracket is drawn to represent that all of this is a single group. It's a single. Notice that I'm not putting a bracket on this end also, just over here. Okay, now we're going to solve this system by hand at first, and then we're going to show you how to do so with our calculator. But our first thing about matrices is that I want to teach you there are a few rules, just like order of operations and just like solving equations. I can add 2 to both sides, etc. Same thing with matrices. There are certain rules. So row operation we're allowed to do. So the first row thing I can do is I can switch my rows around. These are my rows, and they can switch. But notice they always stay in the same order. And so the 4, 5, and 3 have to remain in the same order. But I can switch them. So it's okay. I can just switch the entire row. So that now means 4, 5, 3 is down below, and the 3, 2, 6 is above. Again, the whole group just shifts. So I can switch the rows there. I am also allowed to multiply a row by a constant. The constant can be positive or negative. In fact, the constant can be a decimal, a fraction, etc. So here is, I'm going to multiply row 2, the blue one here, by a 3. Okay, so 4, 5, 3. 4, 5, 3 stays on the top. I haven't changed that at all. But now if I multiply the whole bottom by 3, so it's going to be 3 times 3, 3 times 2, and 3 times 6. And we don't have to write this middle step right here. We can just do the product right there. And so now we get the 4, 5, 3, which has not changed. 4, 5, 3 is still on the top. But now I have a 9, a 6, and an 18 down below. Okay, next. Add one row to another. So I'm going to add row 2 to row 1, like this. And notice I'm going to leave row 2 down below. 3, 2, and that 6 is still there. That 6 is still there. But now, the top, we're just going to add to the bottom and keep it up on the top. So look, 4 plus the 3 is going to go on top. 5 plus the 2 is going to go on top. And 3 plus the 6 is going to go on top. So 5 plus the 2, and then the 3 plus the 6. And so again, keeping our 3, 2, 6 on the bottom. And now we get 7, 7, 9. 7, 7, 9. All right. And we can combine all these steps and move these around in order to solve the system. So that's the next page here. So what is the solution of the system? And this is the one we've already seen before. So we already know what the answer is. My expectation is that we're going to get 7, -2. And we did that from our warm-up. So I'm going to be using an algorithm, a process, and I'm going to convert this whole thing to something called reduced row echelon form. The abbreviation for that is RREF, and we're going to see that on our calculators in a little bit. So first things first, let me rewrite this whole system into a matrix. 1, 4, -1, 2, 5, and a 4. So our goal is to get ones and zeros. I would like to get a 1 and a 0, combine things somehow to get ones and zeros in order to isolate my x and isolate my y. So first thing is first. I want to double the top, or actually multiply by -2, because when I combine it with the bottom, these drop out. So I'm going to write the next one, and then I'll show you what my brain was doing in just a moment. Okay, so I am going to -2 this and combine it with that. In doing so, I get a 0 on top, because -2 combined with that gives me 0. Now when I -2 and multiply this, I get -8, and then combine it with that, I get a 3, a -3. And now when I negative double this, I get a +2, and when I combine it with that, I get a 6. And notice the bottom row, the 2, 5, and 4 stays the same. I'm not going to change that at all. Okay, now let me show you what I was doing over here. We have a 1, 4, -1. What I did there was multiply that by -2, because I did 2, 5, and 4. That's the same as below. And then I added those together. So that here gives me a 0. That gives me here a -3. And this here gives me a 6. So notice then I took that here and I placed them there. But you don't need to show this work right here. You can do things in your head. Okay, now the next thing I want to do is, now that I have a 0 here, I want to get just 1x. So how do I do that? Well, if I multiply this by a -1/3, I have to repeat that all over the place. So let me multiply that by a -1/3. I get a 0, I get a +1, and -1/3 gives me a -2 there. And notice the 2, 5, 4 is going to stay the same. Okay, now just to show you over here what I've done, I take the 0, the -3, and the 6, and what I did was multiply that by a -1/3. So in doing so, I got a 0, a +1, and a -2. And then I placed that there on the top. Okay, now technically, I already have the value of x. So now I'm going to repeat that process, but I want to kill this right here. Well, notice that if I multiply the top by -5 and then combine them, I get this right here. I get the opposite. So multiply the top by 5. I'll show you my brain over here first. So multiply the top by -5, like so, and have the 2, 5, 4 underneath. Okay, so let's do that. The top by -5, that gives me 0 here. So 0 plus 2 is still 2, no change there. Now, -5 times 1 is a -5, and then add that here to get a 0. Perfect, because the y values are now 0. And now the -5 times the -2 is a 10, and when I combine those, I get a 14. So that's 14 right there. So the top is going to stay the same, 1, 0, 1, -2. Excuse me. And the bottom is now a 2, 0, 14. Now I did run out of space here, my apologies, so I'm going to have to do the work over there. Okay, now the last thing I need to do is just like I did here. Notice I need to get from the -3 to a 1. So here I need to get this 2 to a 1. So cut everything in half. That's it. Cut everything in half. So the top is still 0, 1, and I'm forgetting the bar there, -2. Cut the bottom 1 in half to get 1, 0, and 7. And Here we go. What do you mean, here we go? The value of 1y is equal to negative 2. The value of 1x is equal to a 7. 1y is a negative 2, and 1x is a 7. And that should look familiar because 7, negative 2 was indeed my solution. Was indeed my solution. 7, negative 2. Okay. So how do you do this one? I want you to go ahead and work on it. Pause here. Now that we wrote our matrix, I need to cancel out. I need to get zeros, right? So if I double the bottom and combine it with the top, I get a negative. I double the bottom to get a negative 2 and combine it to cancel that out. So double the bottom and combine it with the top. So the top stays the same, 2, 5, and 5. Double the bottom and combine it. Double the bottom here. This gives me a 4 and combine it with that. That gives me a 9. And then double this one as negative 14 and combine it with the 5 there to get a negative 9. Now let's go ahead and 1/9 the bottom. 0, 1, negative 1. Great. Now what about the top? Okay. To get opposites here, if I multiply the bottom by a negative 5 and combine it with that. So the 2, 5, and 5 stay the same. Sorry, it doesn't. The 0, the 1, and the negative 1 stays the same. But if I multiply the bottom by negative 5, I get negative 5 here, and that gives a 0. So there's a 0 there. Multiply this by negative 5, and combine it with that, and I still get a 2. And multiply this by a negative 5 to get 5, and combine it with that to get a 10. Now what? Well, if I take this guy right here and cut everything in half, I get 1, 0, 5, 0, 1, negative 1. And there are my answers. X is 5, and Y is negative 1. Now this is a funny method because it feels like it takes so long, and there's a lot that's going on in our heads that we're not necessarily showing, although you're welcome to show that over there. Okay. Now, this last page here, I'm going to let you scan this and watch this video, or it's in the link below, and we're going to show you how to solve the system using our handy-dandy calculator. So go ahead and attack, kill, destroy that. And then I want you to do these problems down here using your calculator and using the ref function. Come back here and check the answers. By the way, there's a small little mistake here. That Z right there should actually be an A. And here are the answers when we use the ref function. And now go ahead and do this one. Note that there's no X right here in this one, so put a 0 in for that one. And here are the answers for this one. Have a great day.